Assalamu alaikum dear students, hope you are fine with the grace of Almighty Allah. Welcome to NAVS Home School. I am Sabreena Haque, assistant teacher of Science, National Ideal English Version School, Leadership. Dear students, today I am going to take a science class for class 8 student on the based on chapter 11. The name of the chapter is light. So let us move forward to this topic. Dear students, the name of the chapter 11 is light. When a ray of light crosses obliquely from one transparent medium into another transparent medium, it is bent at the interface. This is the refraction of light, and this is the definition of refraction of light. And here, this obliquely is the condition. This obliquely is the condition for refraction of light. We already learned reflection of light in class 6 science book, and now we are going to learn elaborately about the reflection and refraction, and that in this chapter. And with this we will also learn about our eyes, which also we learn in class 6 science book, and also there is the similarity of the eye and the camera, that we will similarity and dissimilarity or comparison we will learn in this chapter. So let us move for our lesson 1, the refraction of light. Then when we stand in front of a window, that time we can see outer scenario, and with the outer scenario we can see our blurred image, because when light is going through the window, that time light go through it. That means light can pass through the transparent medium, and that's why we can observe the outer scenario of window. And when we are nearer to the glass, we can see our blurred image, because not all the light rays refracted, some of it comes back from the window. That's why there we can see a blurred image. Now come to activity, concept of refraction. This is a glass, clear glass, and that there inside the water we can, if we put a spoon or put a pencil, after putting that pencil we can see there is the portion above the water that seems to us that is broken. That is because of refraction of light and for the different medium, because this is the water, that is the denser medium, and this is the air inside the glass, that is the rarer medium than the water. The rarer means lighter, and because of this, that water when this we look to the glass obliquely, that time the pencil is seems to us it is broken, but it is not a real image, it is a virtual image of the pencil. This is caused because of the refraction of light. In the above experiment, light from the immersed part of the pencil reaches us after refraction, and before the light from the immersed part of the pencil reaches our eyes, it passes from the denser transparent medium water and rarer medium air and deflected in the surface, and the apparent bending the pencil gives evidence the light is refracted at a surface between the two defined media. Thus, bending of light path at the surface separating two media and occurs because the velocity of light different in different medium. We already learned about this. Velocity of light and velocity of sound is different in different media, and it is to be noted that light falls normally on the surface and there will be no change of direction of light, but when it go from a denser medium to rarer medium, from a rarer medium to denser medium, that time it changes its direction. Now come to next one, that is the law of refraction, that we have to learn. Law of refraction or condition of refraction, that light rays always follow the law of refraction. Do you this is the experiment. We have to take a glass jar, heavy glass slab, that with glass slab by putting the pins we can indicate the light is going through it. And look, if it is the glass slab and if we put a pin here and this is the normal, this perpendicular is known as the normal, n prime. Then this is air, this is glass, this is rarer medium, this is denser medium. When light enters to the glass, light's direction was that, but because it is denser medium, light entered from the rarer medium, that's why it turns to the normal. That means it comes to the normal. This is the normal, the light ray comes to the normal and it falls here. In that point we have to draw another normal, that will be m prime, and this is the direction of light. And because this is the denser medium and it comes again to the rarer medium, this direction was in this way, but because it comes again to the rarer medium, it go away from the normal. It go away from the normal, and this angle is known as angle of incident. This angle is known as, this is the incident ray. This ray is known as incident ray. This angle is known as the angle of incident. This angle is known as angle of refraction. I is angle of incident, R is angle of refraction. And here when light incident ray enter into from the rarer medium to denser medium, that means when light ray enter from the rarer medium to the denser medium, that time I is greater than R. I is greater than R. When light rays enter from the rarer medium to denser medium, that time I greater than R. This is the first law of the refraction. Now come to next one. If light ray comes in straight line, that time there will be no change of direction. There will be no change of direction. That's why when I say about the definition of refraction, that time I say light have to be fall obliquely. That means angle of incident, angle of refraction, all will be 0. This will be third law of the refraction. This is the first, this one is the third. And again, when light rays comes to the denser medium to rarer medium, that time the angle of, if this portion we are thinking, this one is I, light is entering from denser medium to rarer medium, this one that time will be R. That time denser to rarer. That time I is smaller than R. I is smaller than R. That means when light rays enter from denser medium, this is rarer medium to denser medium, I kept greater than R, and when denser medium to rarer medium light enters, that time I is smaller than R. That is the first condition or first law. Come to now second law. In that case, light enter to a different medium, from rarer medium to denser medium, and it again come back to rarer medium. That means same medium. And that time this angle known as angle of emerge. This angle known as angle of emerge. And always the angle of incident and angle of emerge will be equal, because this measurement of I, this is same air and this also air, and here from air the light enters to the glass, and here the light enters from the glass to the air. That's why the angle of incident, this is the second law, angle of incident will be equal to angle of emerge. That is written in your book page number 116. That means come to page number 116. When a ray of light enters from the rarer medium to denser medium, then it bends towards the normal, and it is in this case the angle of incidence is greater than the angle of refraction. Second one, when the light ray is reflected from one medium like air into another medium like glass and finally emerge out from the original medium, the angle of incidence equal to the angle of emergence. That means here I greater than R, here I is equal to E, and here now come to the next law. That means incident ray, reflected ray, normal drawn at the incident point or on the surface separating the two media all lie on the same plane. This is the condition of refraction, and in the addition it is observed from the above experiment that light ray passes through from denser medium to rarer medium, bends away from the normal, and this is in this case angle of incidence is smaller than the angle of refraction, and when the ray of light is incident along normal, then the angle of incidence and the angle of refraction and the angle of emergence all will be 0. So in this case there will be no change of incident ray. So these things are the law, and you have, or the condition, you have to learn this, and it will be your homework also. Now come to the practical application of reflection. Now come to first one that we already learned. That means if we fill up a glass with half of water and we put a pencil here, that or a spoon here, that seems to us that pencil or spoon is broken. Now come to next one. That is, if we take a beaker filled up with water, and if we put a coin, that coin's real position is here, but when we look obliquely from the top of the beaker, that coin seems to some above of the real one. That means that there will be a virtual image of the coin. That upper one is the virtual image of the coin. If you observe it at home, you can easily observe this because of the refraction of light, that virtual image created on that position. That means that above of the real position. Now come to next one. that is the fish. If you look from the top of the aquarium or in the pond, that full fish is look some above than its real position, and it is happens, and fishermen follow these rules for fishing, and it is, if you observe that fish is looks some closer to you, but it is not its real position, it is the virtual image. Now come to the next lesson, that is total internal reflection and critical angle. And when the light ray entered the rarer medium to denser medium, the reflected ray bent away from the normal drawn at the point of incident ray. As a result, the angle of refraction become larger than the angle of incident. In this way, the angle of incident increasing the corresponding angle of refraction, and particular combination of such pairs media, there is a particular value of angle of incident, and which in this case must be smaller than 90 degree. The corresponding angle of refraction become 90 degree. That means, which means the reflecting ray passes along the surface separating two media, and the angle of incident which is corresponding from here we have to make the definition of critical angle. The angle of incidence which correspond to the angle of refraction is 90 degree is known as critical angle. Now what will be happen if angle of incidence is greater than the angle of critical angle? The angle of refraction can be naturally be greater than 90 degree. Now come to the figure, what will be happen. This is water, and the condition is light must be goes from the, this is denser medium, that means water, and this is rarer medium, that means air. And first we will draw a normal, and this is the angle of incident. If we learned just now that if the light, this is the angle of incident, this is the angle of refraction. If light rays comes from the denser medium to rarer medium, it's bent away from the normal. That time I is equal to, sorry, not equal, I is greater than, smaller than R. That means R is greater than I. Now this is specific for different medium, for which incident angle the reflectant ray go through the separating of the two medium, go through the surface of separating the two medium. That means it becomes 90 degree. These angles become 90 degree. R's value becomes 90 degree for which incident angle, that angle's value is known as critical angle. That value is known as critical angle. And now come to the next point. If the incident angle is greater than the critical angle, if the incident angle is greater than the critical angle, what will be? Critical angle is expressed by theta. Expressed by theta. If the incident angle is greater than critical angle, what happened? R will be greater than 90 degree. That time R will be greater than 90 degree, and if that is greater than 90 degree, what will be happen? The light rays will not go the another medium. It comes back again to the same medium. That means if the incident angle is greater than critical angle, that time light ray will not go to the different medium, next medium, or it will come back, it will be same medium, and that incident is known as total internal reflection. I am saying again, if incident angle is greater than critical angle, that time light ray do not go to the another medium, it comes back again to the same medium, and we know when light ray fall on a surface and it comes back, that is known as reflection, and that's why this is called total internal reflection. That means if incident angle is greater than critical angle, there will be no refraction, but there will be total internal reflection. Now come to the condition of the total internal reflection. First condition is it occurs only when the light rays goes from a denser medium to the rarer medium, and second one, the angles of incident in the denser medium must be greater than the critical angle corresponding to the pair of media chosen. Dear student, this also your homework, and you have to learn this. And law of refraction also condition, that is not condition, that will be law. Laws of refraction. Now come to your homework number 5. Laws of refraction with figure, and second one, condition of total internal reflection, that you have to write in your homework copy as your homework number 5. Dear students, I have finished my today's topic. Learn this chapter because this is so much important, and the next part of the chapter you will get in your class 9. So do the SW, submit it, and thank you.